Hello, my dear mechanical and civil engineers. Myself, Chandrasekhar, welcoming you all to this wonderful Ground Zero series. In this series, we bring the most important concept through animation so that it becomes easier for you to understand the concept as well as it becomes interesting also for the students' benefit. All right. So, in today's session, I will be talking about I'm going to discuss about the important, simple yet fundamental questions from the subject fluid mechanics, which is common for civil as well as mechanical engineers. So I am having around 10 questions, which are very basic, simple, but yes, it will improve your fundamentals. It will improve your understanding of the concept, whether you are able to apply the concepts or not. All right. So, but before that, please do let me know if I'm audible and visible to everyone. Can you guys hear me so that we can start the session? Just a second, hold on. All right. So those who are watching me live, please respond through the comment section if my audio and visual quality are fine or not. And do keep your pen, notebook and calculator because you are supposed to solve the questions. And if you face any difficulty, any doubt, I am there to help you out. You can raise your concern through the comment section. So, Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalamu Alaikum. Please get yourself settled down fast, guys, so that we can start this wonderful session. Very, very beneficial for all the GATE 2024 aspirants. So before I start, this is my quick introduction for those who are here for the very first time. My name is Chandrasekhar. As I said, I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have also cleared engineering services examination. I had worked in Steel Authority of India Limited also for a couple of years. So I am quite comfortable in the mentioned subjects, and the fluid mechanics is common for civil and mechanical. Please do write me in the comment section who is from mechanical. Please do write M in the comment section for mechanical engineer, and please do write C for civil engineer. And do not forget to share the link of this session to all your friends who are going to appear for GATE 2024 exam. All right, mechanical, Roshan, ADM. You can connect with me through the mail ID which is there on the top of the screen. And also you can join me on the Telegram, that is Mechanical by Chandrasekhar. The link is also there mentioned on the bottom of the screen. So once you become part of my Telegram group, you will be getting the exam notifications. Notes will also be provided to you. All the PDF of the sessions will be shared through the Telegram group, and there will be one-to-one doubt clarification can also happen. If you have any doubt, you can share your doubts through the Telegram group. So it will always be beneficial for you to be part of our Telegram groups. All right. So shall we start? Please keep your pen, notebook and calculator and try to involve yourself as much as you can. Give me your answer through the comment section. And before we start the session, there is an important announcement for all the GATE 2024 aspirants. So Dheeraj sir and Ashutosh sir will be taking a workshop, very, very important workshop for all the GATE aspirants to discuss about the complete roadmap, complete plan for clearing the GATE examination with the best possible score. The workshop will be completely free and it will be on 14th of March at 7:30 p.m. You can register yourself for the workshop and share this information to all your friends as well. All right. So let us start with the first question. The link for workshop is already there in the description box. You can go through the description box and please do like, share and subscribe our BYJU'S exam prep YouTube channel for more updates about the various sessions which we conduct from time to time for the students' benefit. So let us start with the question number 1. Question number 1 is on your screen. The question says the rate of change of pressure in a vertical direction, in a z direction, is directly proportional to weight density of the liquid or specific weight of the liquid. This phenomena or this law is related to which law? There are 4 options and out of them only one option is correct. Newton's law, Pascal's law, Archimedes' law, or hydrostatic law. So you will be having 10 seconds to select your right answer, to give me your answer through the comment section. What is the correct answer? Every one of you, I want everyone to respond. Kiran, Roshan, well done. Good evening, guys. I welcome you all once again from the bottom of my heart to this beautiful session of fluid mechanics, that is the numerical practice session. So if we see, the Newton's law is for viscosity. The Newton's law is applied or defined for the viscosity of the fluid. That is called as Newton's law of viscosity in fluid mechanics. According to Newton's law of viscosity, shear stress is directly proportional to rate of angular deformation or velocity gradient. So it is not related with the pressure. Pascal law is related with pressure. According to Pascal law, pressure is remain constant in a horizontal plane. Pressure is neither be a function of x nor y in a horizontal plane. That is the Pascal law. So Pascal law is related for a horizontal plane, not in a vertical plane. Archimedes' law is about the buoyant force. According to Archimedes' principle, the buoyant force is equal to weight of the fluid displaced by the immersed body. When a body is immersed in a fluid, the buoyant force is equal to weight of the fluid displaced by the body. It is the hydrostatic law. It is the hydrostatic law which says dP by dz, pressure varies in a vertical direction, is equal to the variation of pressure in vertical direction is given by this expression. That is called as hydrostatic law. Those who have given option D as the answer, Sapna, it is D for Delhi. Sandy, welcome guys, good evening. Please do like this session so it reaches to all your colleagues, all your friends who are going to appear in GATE 2024 examination. Let us move to question number 2. And do check your analysis, how many questions you are able to solve, how many questions you are unable to solve, and the concept which you are not very much comfortable with, please do revise those concepts as well. So let us move to question number 2. Hi Venkat, welcome, good evening. The question number 2 is from the mass conservation applicable in the fluid kinematics. The continuity equation, this expression of continuity equation is valid for, only for, let us have the 4 options. It is valid for the ideal flow. It is valid for the compressible fluids and unsteady flow. Option C says it is valid only for the steady flow. And option D is it is valid for incompressible fluid, whether the fluid flow is steady or unsteady. What is the right answer for this one? And your time starts now. So I want everyone to keep responding. Yes, every one of you. Though the questions are very simple but conceptual, I have handpicked these questions from each and every corner of fluid mechanics so that you will be able to apply those concepts here and you will develop the confidence and you will be able to improve your thought process. That is the agenda of having this numerical practice session. We will be coming with more tougher numerical questions practice, but because it is the very beginning for 2024 aspirants, so that is why the questions are taken very, very simple. Yes, again, if we talk about the continuity equation is all about the mass conservation. So the generalized continuity equation, if you apply the mass conservation in case of a control volume, then general continuity equation will become del rho by del t plus del by del x, rho into u is the velocity in x direction, plus del by del y, rho into v plus del by del z, rho into w is equal to 0. That is our general continuity equation. Now, do you know what is a steady flow? Steady flow is the one which is non-viscous plus incompressible plus steady. That is called as ideal flow. Sorry, I was talking about ideal flow. Ideal flow is the one which is non-viscous, steady and incompressible. Now let us talk about the incompressible flow. What is incompressible flow? Incompressible flow means density is neither be a function of space nor time. Density remains constant for an incompressible flow. The liquids are incompressible. Example, liquids, the density of liquids are treated constant, are taken constant. So if density is not a function of time, this term will become 0. If density is not a function of x, it will be taken outside. If density is not a function of y, it can be taken outside the differentiation. If density is not a function of z, it can also be taken. So the expression will be rho into del u by del x plus del v by del y plus del w by del z is equal to 0. Can we write? Because density is neither be a function of space nor time. If we take density on the right hand side, then our expression will be del u by del x plus del v by del y plus del w by del z is equal to 0. Is this clear? So this expression is only valid when the flow is incompressible. Whether the flow is steady or not, it does not matter. Because when the flow is steady, it means this term will be 0 only. Rho can be a function of x, rho can be a function of y, rho can be a function of z. So the more appropriate answer to the question number 2 is option number D. When the flow is incompressible, it does not matter whether it is steady or unsteady to apply this modified expression for continuity equation. I hope it is clear. औरंगजेब गेट न्यूमेरिकल्स करने के लिए आप अगर फ्लूइड मैकेनिक्स की बात कर रहे हैं तो फ्लूइड मैकेनिक्स के गेट के प्रीवियस ईयर क्वेश्चंस आर द बाइबल टू द गेट एग्जामिनेशन. Go for previous year question for mechanical engineering, go for previous year question for civil engineering, go for previous year question for engineering science paper as well. So there are so many questions from the previous year fluid mechanics you can practice, right? Let us move to the next one. Question number 3. Question number 3 on your screen. Read the question very carefully. Very, very beautiful question. Flow of a fluid from low pressure region to high pressure region. So many students have a doubt that fluid always flow from high pressure region to low pressure region. That is completely the wrong notion students are having. The flow can take place from high pressure to low pressure. The flow can also take place from low pressure to high pressure. So which of the following cases will have the fluid flow from low pressure region to high pressure region? The options are on your screen. Option A is when the flow is upward through a uniform vertical pipe. Option B says flow through a converging pipe with a horizontal axis. Option C says flow through a diverging pipe with a horizontal axis. And option D says the flow from low pressure region to high pressure region is impossible if the passage has a constant cross-sectional area. Yes. Who will give me the right answer for this one? Your time starts now. Every one of you, please flood the comment section with your answers, with your response. And those who have joined me late, it is my humble request to all of you, please do not forget to like this session and share this session to all your friends who are going to appear in GATE 2024 examination. Do not be afraid of committing mistake. Even if you are not getting the right answer, it does not matter, because your mistakes will teach you the concept in a better manner. The learning cannot be done without mistakes, without errors. So you should be ready to do the mistake and accept your mistakes and try to improve those areas which you are not comfortable with. The question is from the Bernoulli equation. This is the question from the Bernoulli equation. Yes, I am getting the answer B as well as C. I am waiting for every one of you to respond. According to Bernoulli equation, so what we can say, according to Bernoulli equation, P plus rho gz plus rho v square by 2 is equal to constant. That is the Bernoulli equation. P plus rho gz plus rho v square by 2 is equal to constant. That is our Bernoulli equation. Now, if the pipe is vertical, for a uniform vertical pipe means velocity is constant. For a uniform pipe, it means velocity is constant. For a uniform pipe, velocity will be constant, isn't it? Because area is constant. According to mass conservation, velocity is constant. So we can say P plus rho gz will be constant. P plus rho gz will be constant. So upward means z is increasing. If z is increasing, P will decrease. Then only P plus rho gz will be constant. So in the direction of the flow, the pressure is decreasing. If potential energy is increasing, upward flow means z is increasing. So the pressure is decreasing. So it is the flow in the upward direction will be in the direction of decreasing pressure. So flow through a converging pipe. Converging means decreasing area. So if area is decreasing, velocity will increase. Horizontal axis means z is constant. Z is constant. So we can say our Bernoulli equation is P plus rho v square by 2 is constant. So if velocity is increasing, again the pressure will decrease. So it is also in the direction of decreasing pressure. B cannot be correct. If we talk about flow through a diverging pipe means increasing area. If the area, flow area is increased, the velocity of flow will decrease and the pressure will increase in the flow direction. Z is constant. So here in a diverging pipe, the flow is taking place in the direction of increasing pressure. If we talk about option number D, if we see option number D, if the cross section is constant, if area is constant, area into velocity is constant, so velocity will be constant. So for option number D, we can say P plus rho gz is equal to constant. So can we have the flow to be in the direction of increasing pressure? If Z is decreased, then in the flow direction, pressure will increase, isn't it? Pressure will increase in the direction of flow when the Z will decrease. It means if the flow is downward, if the fluid flow is taking place in downward direction in a constant cross-section pipe like this, then the pressure will increase in the flow direction. So it is impossible is not correct. Option C will be the correct answer. All right. Let us move to the question number 4. Is this clear to all of you? Please give me yes in the comment section. Every one of you, please do write yes in the comment section. So after the class, do go through the description box. There are multiple links, many links mentioned in the description box, which will be helpful for you. If you want free ebooks for your GATE preparation, you can select the link and do not forget to subscribe our BYJU'S YouTube channel. Ready for question number 4. औरंगजेब MSQ अभी नहीं करवाएंगे. This is just the beginning. So we will have all type of sessions which are important for your GATE preparation. So stay with us, subscribe our BYJU'S Exam Prep YouTube channel and do join our Telegram group. We will give you the notification for all these beautiful sessions which we will be coming with in the near future. We will have marathon sessions also. We will have numerical practice sessions, MSQs, MCQs, NATs, etc. Every type of help we will be providing you. It is only the hard work which you are supposed to do. Question number 4. Question number 4, read the question. The loss of head, it is from the head loss in a pipe of 100 meter length carrying oil, the fluid is oil. Volume flow rate is 100 LPS. What is LPS? That is liter per second. Is estimated to be HL. If a pipe of double the diameter but of same length is to carry a discharge of 200 LPS, liter per second, it means twice the discharge, then head loss will be. Options are already there on the screen and your time starts now to select your answer. Yes, every one of you, there are only 10 questions in total. If you do not practice the question, somebody else will be getting better and better. So do not only revise the theory again and again. You should always keep on practicing the numericals also to get yourself comfortable with the application part of it. What is the correct answer? So if we say head loss is due to friction, according to Darcy-Weisbach equation, according to Darcy-Weisbach equation, the head loss due to friction is given by FLV square by 2GD, or we can write it as FLQ square upon 12.1 D to the power 5. That is the expression for calculating the head loss due to friction. The flow must be steady and uniform. The only condition is the fluid flow must be steady and uniform. So if we analyze this, the question is from the relation based. The length is constant, discharge is getting doubled, and the diameter is also getting doubled. Then what is the ratio of HL? So we can say F is constant, length is taken constant, 12.1 is constant. So we can write HL is proportional to Q square upon D to the power 5. So from here, HL2 upon HL1 is equal to Q2 by Q1 square into D1 by D2 to the power 5. Q2 by Q1 is 2, 2 square into 1 by 2 to the power 5. So it will be 2 to the power minus 3. That is 1 by 8. The ratio will be 1 by 8. So HL2 is equal to HL1 upon 8. So the right answer to this question is option number D. Option D will be the correct answer. Well done, guys. Well done. Keep it up. Let us move to the next one. Question number 5. We are halfway now. The next question is from the external flow or the boundary layer theory. Read the question and try to get me the answer. Yes, Arunita, Sapna, well done. Roshan, Kiran, guys, keep it up. You will not become the expert in a single day. The expert in anything was once a beginner. So it is just your beginning. Keep your momentum high, keep your motivation high. Do not look back. Keep on improving yourself day by day. Automatically, you will become expert of your subjects. The ratio of turbulent boundary layer thickness to the thickness of laminar boundary layer varies as. Options are on your screen. In terms of x, it is x to the power 1 by 2. Option B says x to the power 4 by 5. Option C says x to the power 10 by 3. And option D says x to the power 3 by 10. The question is from the boundary layer theory. Yes, every one of you, please get me your answer. Your time starts now. Read the question carefully and get me your correct answer. Yes, it is the ratio of turbulent, delta for turbulent divided by delta for laminar. The thickness of turbulent boundary layer to the thickness of laminar boundary layer. So for turbulent boundary layer, delta is proportional to x to the power 4 by 5. For turbulent boundary layer, when the Reynolds number is greater than 5 into 10 to the power 5. For laminar boundary layer, when the Reynolds number is less than 5 into 10 to the power 5, then delta is proportional to x to the power 1 by 2. So if we want to find out delta t by delta L, then it will be x to the power 4 by 5 upon x to the power 1 by 2, isn't it? X to the power 4 by 5 minus 1 by 2. Can you solve it? X to the power 4 by 5 minus 1 by 2. So it will come out to be 3 by 10. Yes, Kiran. Yes, Sandy, Arunita, Sapna, Roshan. Well done, guys. Well done. Option D is the correct answer for this one. Option D is the right answer. Shall we move to the next one? Question number 6. There are only 4 questions after this. Question number 6. Read the question very carefully and try to get me the answer. The difference between ordinary and extraordinary is the practice. You can become extraordinary in your subjects when you will have a regular practice, and not only the practice, you whatever your mistake, you should analyze your performance every now and then and try to improve it wherever and whenever it is required. The next question is from the kinematics of the fluid. So the fluid flow or the flow field velocity vector is given by this expression. Now the question says what will be the equation of the streamline which is passing through the point 1, 1. There are 4 options already mentioned on the screen. Every one of you, please try to find out the answer to this question. The streamline equation of the streamline. Yes, I am waiting for your response for the equation of the streamline. And those who have joined late, please do not forget to like this session. This gives us appreciation. This gives us motivation to bring the concept, bring the sessions, simple and wonderful, important sessions for you, so that it is going to help you a lot in your GATE preparation. So if we talk about the equation of the streamline, this is our velocity vector. First of all, compare it with general velocity vector. It is 2-dimensional flow. The flow is 2-dimensional, so the velocity vector can be written as ui cap plus vj cap. U is the velocity in x direction, v is the velocity in y direction. If we compare these two, then u will be equal to a into x, v will be equal to minus a into y, isn't it? So if we talk about differential equation of streamline, what is the differential equation of streamline? dy by dx is equal to v by u. That is the differential equation of the streamline. So dy by dx is equal to v. What is v? Minus ay upon u, that is ax. A getting cancelled out, separate the variable. Dy by y is equal to minus of dx by x. Do the integration to get the equation of the streamline. Integrate this equation. Integration of dy by y is ln of y is equal to minus ln of x plus constant of integration. So this constant can be taken as natural log of constant. This constant can be taken as ln of constant. So we can say ln of y is equal to ln of c by x, isn't it? So log will get it cancel out. So x into y is constant, is the general equation of the streamline, but it is specifically asked to find out. So xy is equal to constant is the general equation of the streamline, but we want to find out the equation of the streamline passing through point 1, 1. So at x is equal to 1, y is equal to 1, it will give rise to c is equal to 1. So our equation of the streamline which is passing through 1, 1 is option C. Option C will be the correct answer to this one. So that was question number 6. Let us move to the next one. I hope every one of you is enjoying the session. If you have any doubt in theoretical part, in conceptual part, please do let me know through the comment section. Otherwise, allow me to proceed to the next one. The next question, question number 7 on your screen. Read the question and do find out the answer. The length of the laminar part of the boundary layer. It is again from the external flow boundary layer theory. The length of the laminar part of boundary layer on a smooth flat plate is 25 centimeter. If the viscosity of the fluid is 0.1 stock, which viscosity is given? Is it dynamic or kinematic? It is all decided by the unit whether the dynamic viscosity is given or the kinematic viscosity is given. I have been telling you every now and then the unit of a particular parameter is going to be very, very important to decide which viscosity, which density, or is it the mass flow rate or the volume flow rate. So what is the velocity of the free stream of the fluid? U infinity is how much? Let us have a look to the options. 5 meter per second. Without option, Kiran had given the answer. Option B says 10 meter per second. Option C says 12.5 meter per second. And the option D is 20 meter per second. And your time starts now for getting your answer to question number 7. Your knowledge is of no value unless you put it into practice. The more you practice, the more refinement in your knowledge take place, and that is the need of the GATE examination. GATE does not talk about the theoretical knowledge, it always talks about the application of your concepts. So what is the correct answer to this one? Arunita, Sapna, Sandy, please do let me know. Every one of you, look, the Reynolds number, the maximum value of Reynolds number for laminar is given by U infinity into X maximum upon kinematic viscosity. That should be 5 into 10 to the power 5. So this is X maximum where the laminar flow is taking place. So we can say U infinity is unknown, X maximum is 25, 0.25 meter upon kinematic viscosity 0.1 into 10 to the power minus 4 meter square per second is equal to 5 into 10 to the power 5. The only unknown is U infinity. So U infinity is equal to 5 into 0.1 into 10 to the power 5 into 10 to the power minus 4 upon 0.25. If you will solve this, then you will get option D as the answer. Yes, Roshan, Arunita, well done. Sandy, Sapna, good, good, good. Keep it up. The free stream velocity is given by 20 meter per second. Let us move to the next one. Question number 8. Third last question. The question is from the basic fluid property, that is bulk modulus. What pressure must be applied to water to reduce its volume by 0.092% if the bulk modulus of elasticity of water at a temperature of operation is 2.19 gigapascal. 1 gigapascal is equal to 10 to the power 9 pascal, isn't it? So the options are on your screen. Option A says 20 megapascal will be the pressure applied. Option B says 200 kilopascal. The unit are very, very important. Option C says 0.2 gigapascal and option D says 2 megapascal. What is the correct answer to question number 8? Your time starts now. Every one of you, please do solve it and get the correct answer. The best preparation for tomorrow is giving your best today. If you are working hard today, then definitely tomorrow will be bright. If you are not working hard today, if you are not serious, sincere today, then tomorrow will be difficult. What is the correct answer? So the bulk modulus is given by direct normal stress upon volumetric strain, isn't it? That is the formula. Bulk modulus is given 2.19 gigapascal. So the reduction in volume is 0.092%. So we can say delta V minus delta V by V into 100 is equal to 0.092. So minus delta V by V is equal to, if we put the value 2.19 into 10 to the power 9 is equal to pressure applied upon 0.092 upon 100, isn't it? So it will be 2.19 into 0.092 into 10 to the power 9 upon 100, isn't it? So it is around 2 into 10 to the power 6 pascal. It is 2 into 10 to the power 6 Pascal. And 1 megapascal is equal to 10 to the power 6 Pascal. So we can call it as 2 megapascal. Delta P will be equal to 2 megapascal. Option D is the correct answer. Option D will be the right answer for this one. Let us move to the next question. Question number 9. Second last question. Very, very beautiful question. A cubic tank of 2 meter side is filled with water up to top. The force acting on one side of the tank. The question is from the hydrostatic force, but there is a catch. There is a twist. The force acting on one side of the tank when it is accelerated, when the tank is accelerated at g by 2 meter per second square vertically upward. So you need to find out the force exerted in kilonewton, and you are supposed to take g as 10 meter per second square. Yes, options are on your screen. 15 kilonewton. Read the question carefully, draw the diagram and do the analysis. Beautiful question. 15 kilonewton or 30 kilonewton, 45 kilonewton, or the last option says 60 kilonewton. Yes, please solve it and do let me know your answer. The success is actually a journey full of hurdles. You will feel low, you will feel high, you will feel demotivated, you will feel distracted, but everything you should manage to keep your focus towards achieving your final destination, that is the GATE exam. What is the answer to this one? So let us try to understand. There is a cubic block. Your time starts now to solve this one. Let us have the analysis. Kiran Roshan had given the answer as option D. This is second last question. Let us say there is a cube which is filled with water up to top. Each side is 2 meter. Each side is 2 meter. And it is exerted by acceleration due to gravity G in downward direction. And it is acted upon, or it is moving in upward direction. It is moving in upward direction with acceleration which is equal to g by 2. So because the acceleration is opposite to gravity, so we will calculate effective gravity, which is g plus a, which is g plus g by 2 or 3 by 2g. Now we want to find out the force exerted on one side. This is the free surface. So if we apply the formula rho g a x bar, the force applied, the hydrostatic force applied will be equal to rho fluid into g. It will be g effective into area into x bar. What is x bar? X bar is the depth of, x bar will be the depth of centroid of the plane surface from the free surface. So if we put the value, this is 1000 into g effective is 3 by 2 into 10 into area, that is 2 into 2 into x bar, that is 1. That much will be the Newton. 2 getting cancelled out. So it will be 3 to the 6, 60 into 10 to the power 3 Newton, or we can call it as 60 kilonewton will be the answer if the acceleration is in upward direction. So the answer to this question is option number D. Answer will be option number D. All right. And the last question for the day, I want all of you, at least for the last question, I want each one of you to respond, to give me the answer. The velocity at the pipe axis, it is from the internal flow in a pipe. The velocity of flow at the axis of the pipe in laminar flow, the flow is laminar in a pipe when the Reynolds number is less than 2000. Through a 10 centimeter diameter pipe is 40 centimeter per second. The discharge in liter per second will be how much? You need to find out the discharge in liter per second. Your options are on the screen. Pi by 2. Pi, in terms of pi, you need to find out your answer in terms of pi. 2 pi as well as 1.5 pi. These are the various options. Please try to find out your answer to this last one. Every one of you, please do find the answer. Yes, the last question on your screen. For laminar flow, the flow velocity is given by parabolic curve. The velocity of flow is parabola. The velocity of flow is parabola. And so this is how the velocity profile will be drawn. At the axis, velocity is maximum. So we can say average velocity of flow is half of maximum velocity, isn't it? That will be equal to 40 by 2 centimeter per second. The average velocity is 40 by 2. The average velocity is 40 by 2, 20 meter per second, or we can say 0.2 meter per second. That is the average velocity. And we can find out the discharge, that is pi by 4 d square into average velocity. So that will be pi by 4. What is diameter? 10 centimeter. That is 0.1 meter square into 0.2. So it will be pi by 4 into 2 into 10 to the power minus 3 meter cube per second, isn't it? And 1 liter is equal to 10 to the power minus 3 meter cube. The question is in liter per second, so it will be pi by 2 liter per second. Option A will be the correct answer for this one. Yes, Arunita, Sapna, well done. Kiran, good, Roshan, Yugandhar, well done, guys. Thank you everyone for your active participation. You can connect with me through the mail ID, and you can join me on the Telegram also, that is Mechanical by Chandrasekhar, and you can have your doubts to be cleared through the Telegram group. So I really enjoyed this session. I hope you guys have enjoyed the session. Please do not forget to like this session so that it reaches to all your friends, and do subscribe our BYJU'S YouTube channel. Thank you for joining in. Let me take your leave now. See you in the next session. Till then, enjoy, take care, have a good night, and have a great future ahead. Thank you. Jai Hind, Shubh Ratri, Sabbah Khair. Thanks a lot, guys. Thank you very much.